Today we're looking at Unit 4, Lesson 8, percent increase and decrease with equations. So we're solving percent increase and decrease problems by writing an equation to represent the situation and solving it. So we started off with just some matching problems. Match an equation to each of these situations and then solve the equation to find the solution. So the first one, the water level in a reservoir is now 52 meters. If this was a 23% increase, what was the initial depth? So I'm going to start by making a table to help me make my equation. And so I have now 52 meters. What was the initial depth? So I'm going to put initial depth because that comes first. And the depth now. So my initial depth is going to be my x, and my depth now is going to be my y. So the water level is now 52 meters. And so remember, we need an amount, we need our percent, and it says it's a 23% increase. So that's going to be 123%. And then our constant proportionality then will be 1.23. And so we end up with the equation y equals 1.23x. And we know the depth now, which is our y. So I'm going to put 52 in place of the y. So we get 52 equals 1.23x, which is this one. And then it said to solve it. So we solve equations like this by dividing both sides by 1.23. And I'm going to round to the nearest tenth to get 42.3 meters. And I can go back and check and make sure it makes sense. Since the now is the increase, that means the initial needs to be smaller. The snow is now 52 inches deep. If this was a 77% decrease, what was the initial depth? So again, we have our initial depth and we have the depth now. So I'm going to let initial be x and the depth now be y. 52 is the now. It's a decrease, so I'm going to do 100 minus 77, which is 23. So my constant of proportionality is 23 hundredths, which gives me the equation 23 hundredths x equals y. So that's the top one. And then we put in the 52 for the y. So 23 hundredths x equals 52. We divide both sides by 23 hundredths. And so we end up with x equals, and again, rounding to the nearest tenth, I got 226.1 inches. So it was just a little warm up for today, giving us an idea of matching before we have to come up with everything on our own. So some things we're going to be looking at today. Sales tax. So that's paid to the government. And that's paid on the price of an item. It's a percent of the price of an item. We're also going to be talking about interest, which on a savings account is money that is added. And again, it's a percent of the original amount. And that's paid to the person who owns the account. And we're also going to talk about discounts, and that would be a percent of the original that is taken off of the item. And who benefits from that? The person buying the item. So this was to get us thinking about writing equations even more and just practicing. So a particular savings account increases by about 6% after a year. How much money will be in the account after 1 year if the initial amount is each of the following? And so I'm just going to go ahead and make the table to help me organize it. So I have my initial money, and then I have our money after 1 year. So in this case, the initial is 100%. 6% increase is 106%, which makes our constant of proportionality 1.06. So I could write the equation y equals 1.06x. Y is being the one amount after 1 year. X is my initial amount. And so we can put 100 in for the initial amount, multiply by 1.06, and we end up with $106. If I put $50 and multiply by 1.06, we end up with $52. If we put 200 in and multiply by 1.06, we end up with $212. If we put 125 in and multiply by 1.06, we end up with $132.50. And if I put an X in, I end up with the expression 1.06x. The value of a new car decreases by about 15% the first year. How much will a car be worth after 1 year if its initial value was the following? If you get stuck, make a diagram. So again, I'm just going to go ahead and start with my table. So we have the original amount, and we have our decrease amount. And so the original amount's going to be in my 100%. 100 minus 15 gives me 85%. So I end up with a constant of proportionality of 85/100ths. And then we can just put in each of our initial amounts. And we multiply each of those by 0.85. And so the $1,000 car now becomes $850. The $5,000 car now becomes $4,250. And the $5,020 car becomes $4,267. And for any original amount of my car, X, my new value is going to be 85/100ths X, which means if X is the original amount and Y is the decreased amount, 0.85X equals Y is my equation. So now we had some to write equations. If you need to, you can always go back and make a table. 1,950 people lived in Emporium, PA in 2020. the next year this number had decreased by 1.3%. How many people lived in Emporium? So I'm actually going to make a table. And so for letter A, we have our 2020 population, and we have our 2021 population. And 1,950 is our 2020 population, which would be our 100%, decreased by 1.3. So 100 minus 1.3 is 98.7%, which makes our constant of proportionality 0.987. And I'm not going to round. So to write the equation, I'm going to let 2020 be x because that's what comes first. I'm going to let the 2021 be y. So we have the equation 0.987x equals y. Now we know the 2020 population, and that's my x value. So we're just going to plug that in. 0.987 times 1,950 is going to give me my y. And when you do that multiplication, you end up with 1,924.65. But I can't have part of a person, so we're going to round it up and say 1,925 people. Let's see if we can do the next one without a table. If you need a table, go ahead and use a table. Compared to last year, the population of Boomtown has increased by 25%. Increased by 25%. So that means I'm going to add 25 to 100 to get 125. So my K value is going to be 1.25. All right, so my X is going to equal my last year population. And my Y is going to be my this year population, because last year comes before this year. So my equation would be 1.25x equals y. Well, what do I know? I know this year's population. So I'm going to put that number in for y, since y is this year's population. So 1.25x equals 6,600. And we're going to divide both sides by 1.25. And we end up with x equal to 5,280 people. So letter C. Michelle's Water Company had $4,300 in sales this week. They project the next week's sales will be 105% of the sales this week. What are the projected sales for next week? So since it said of, my K value is 1.05. X is going to be this week's sales. Because that comes first. Y is going to be next week's sales. So my equation, 1.05x equals y. Now we know this week was 4,300. So I'm going to do 1.05 times 4,300 to get my y value. And 4,300 times 1.05 is going to give me $4,515 projected for next week. right, so Tim is buying a new car whose sticker price is $15,000. The car dealer has offered a 10% discount on the car. He also has to pay a 6% increase on the price for the taxes. So how much will he pay for his car? So you may have started off in class by first just looking at the discount. That comes first. So if it's a 10% discount, 100 minus 10 is 90, which means my K value is 9/10. I'm going to let X be my original cost and Y be my new cost. So the equation 0.9x equals Y. And we know X is 15,000. So 9/10 times 15,000 is $13,500 that car is on sale for. But then we have to pay tax to the government. So I'm still going to let X be the original cost and Y be the new cost. But now tax is an added increase. It even says increase. So 100 plus 6 is 106. So that means my K value is 1.06. So 1.06x equals Y. And my original cost now is what the sale price is. So 13,500. And we end up with a new price of $14,310 that we will pay after we pay the government. But there's a shorter way of doing this. We can do it in one step. We can't just subtract the 10% and add the 6%. It's not quite the same. So I set up a table and I said, well, my original cost way back in the beginning, before anything happened, was $15,000. I ended up paying $14,300. Now I know my original is always 100%. I'm going to try to see if I can find that new percent. So constant of proportionality, 14,300 divided by 15,000 gives me 0.954, which means I'm really paying 95.4% of the original price. If we had just said 100 minus 90 plus 6, 100 minus 10 plus 6, we would have ended up with 96. And that's not the same thing. I'm paying a little less than 96%. So then I'm thinking, okay, well, how might I get this? Well, in the original equation, I multiplied by 9/10. And then in the second equation, I took what I got after multiplying by 9/10 and I multiplied it by 1.06. So if I multiply 9/10, I have x times 9/10 times 1.06. If I multiply 9/10 by 1 600, we end up with that 0.954. So we can just multiply our K values and then multiply it by the original amount. And so we need to use that idea in the next one, because Cindy bought a used car for $1,351.50. That was after 15% discount and after the 6% tax. So 100 minus 15 is 85. So my first k value is 0.85. 100 plus 6 is 106. So my second k value is 1.06. X is my original cost. Y is my new cost. So I start and I multiply 0.85 times my original cost, but then I'm going to multiply that by 1.06. So if I do 0.85 times 1.06, because multiplication, it doesn't matter what order we multiply in, we end up with 0.901x equals y. And then the price that we were given is the new cost, the y value. And we can divide both sides by 0.901. And we end up seeing that Cindy's car originally cost $1,500 before the discount, before the taxes. So what we really learned today is that every equation, our k value, is either 100 plus the increase or 100 minus the decrease, written as a decimal. And so x is always going to be our original, y is always going to be our new. So we have that kx equals y. And when we're doing more than one step, we can multiply our k values together to get our final k value to make our equation. Now you're going to try the cool down questions and make sure you get the notes from Google Classroom.